Right, here's two good questions. First one is a Ferris wheel. Okay, they say, oh, the diameter. So radius then would be half of that, or 11. So the radius of the Ferris wheel is 11. And it says, what will the distance traveled to go around once? So they just have to, hop on the Ferris wheel there. They go around once and stop there. So they want to know that distance. So that'll be the arc length. Okay, so my arc, or my formula is the angle is equal to the distance over the radius. Now, one thing, just to make sure that you understand, is that when they give you a rotation, like for the thing to go around once, so that's one revolution going around once. But I know that one revolution in terms of radians, and this angle measurement here always has to be in radians. One revolution in terms of radians is 2 pi rads. Okay? So they say the angle measurement that you turned through is you went around the whole circle once. That's one revolution, or 2 pi. So that's what goes in there. The arc length, that's what we're looking for. And the radius, we know that's 11. So let's solve for s first. Multiply both sides by r. So I get s is equal to theta times r. So the angle measurement is 2 pi times by the radius is 11 meters. And they say, what will the distance traveled to go around once? And hopefully they're leaving it in meters, not changing the units. So 2 pi times 11 would be 22 pi meters, which you could leave like that, but they probably want you to figure it out to a decimal place. So let's go 22 pi. So 69.12, call it. 69.12 meters. And what do they say? Oh, round to one decimal place. So that would be 69.1 meters. Here's another question. This one, I guess it's the same question as the one before, because they're not talking about an angular velocity, so I'm probably just going to be using this formula. So the question says the bicycle tire radius of 35, got that, travel 4 kilometers. So at that distance, if you have your tire like that, and as you travel a distance along this way, that distance along the bottom, because that wheel will just keep going and going, right, turning, and that distance is your arc length. Okay, so I travel 4 kilometers. Now, I have to convert my centimeters and kilometers so they're the same unit. Let's do that. My units are kilometers, hectometers, decameters, meters, decimeters, then centimeters. So if I'm at kilometers, I have to go 1, 2, 4, 5. So 4. So, I'd have to add 5 zeros. There we go. So 4 kilometers are the same as 400,000 centimeters. And they say, how many times will the wheel go around? Well, this formula there, that angle gives me an angle measurement or turn in radians. But they're saying how many revolutions will it be? I do know that there's a formula that says 1 revolution is the same as 2 pi radians. So I'll have to use that conversion maybe at the end. Okay, let's start here then. So they want to know how many times it'll go around. That's some kind of an angle measurement. So angle is equal to, the arc length is 400,000 centimeters. And the radius is 35 centimeters. Okay, let's do that on our calculator here. So it's 400,000 divided by 35. There we go, 133. So that gives me 133,333 point, threes, etc. These cancel out, so my answer for that angle rotation is in radians. But the question says, how many revolutions, how many times will it go around? So I can take that number, 133,000 333.3, etc. radians, and multiply it by, I know 2 pi radians, and I put that on the bottom so I can cancel them, is the same as 1 revolution. Okay, so let's continue on down there with our decimals. So I've got that number, and I'm going to times it by 1 divided by 2 pi. There we go. Make sure if you're doing this on a graphing calculator that you put that 2 pi in brackets. Here I can see it's in the denominator, so it's all is good. Okay, so this will be equal to 21,200, and it says round to the nearest revolution. So 21,221 revolutions. That's how many times the wheel will go around in 4 kilometers. That's a lot of times.